The agenda today is going to really focus on 4 items. The first one, a quick reminder of what Hive is, and obviously hiveDrive, our first product. How do they work? Then we're going to go into the bowels of one of the exciting features that I think we've been all waiting for, which is deleting files. And as we look into implementing it in the right way, we figured out that there are many challenges around the action of deleting files. And then we look at the side effect, benefit of the technology we put in place for deleting files and how hiveDrive keeps your data safe. Then we'll close with the Q&A session. As a reminder, please don't forget during all this session to write up your questions in the Q&A button on the bottom of your Zoom screen, and we'll cover them at the end of our session. We're going to be 3 today in the team to address this agenda. I'll be just doing the opening and the closing of the Q&A, but the gist of the presentation today will be covered by Vincent, who recently joined us, and he is running product for us, and Amin, who I'm sure you've met if you attended the first webinar. If not, he is our head of technology and the brain behind all the challenges that we need to solve to make a peer-to-peer network work for your data. Without further ado, I'm going to give the floor to Vincent, and looking forward to hearing him as well.
Perfect. Thank you very much for the introduction, David. I'm super happy to be here today and to talk to you guys about what is Hive and hiveDrive. It's a good introduction to Amin's presentation about data deletion in Hive. As we see, we'll start talking about what is Hive on the next slide. And the best way to summarize it is that we are operating a network of peer-to-peer computers, phones, servers, and more that are all connected together. We leverage the idle and unused resources of these devices to power the network and to provide capabilities that we build on top of. The first capability that we're offering is an application that we call hiveDrive. What we can see on the next slide is that we're going to target a few use cases. The first one is securely storing, accessing, and downloading your files on top of Hive, where we store all the data in little chunks, which Amin will talk about in a bit more detail. Today, it's free to store your data as long as you contribute 5 gigs or more of space. There's no upper limit. If you want to back up your NAS drive and you have several terabytes or even petabytes free, you can contribute that to the network and you'll get it back in hiveDrive to store all your files. What's really exciting is that if you go to the next slide, we have the delete feature. And you may wonder, oh, why is deleting such a big deal and why we want to talk about it? Well, as you can imagine, we're now active in over 27 different countries. And deleting files that are split up across a bunch of different nodes across the entire world is actually quite tricky. And there's a lot of what I consider to be magic behind it. Now, Amin will talk to us through about how we solve this really exciting magic and turn it into something where you can simply right-click and delete and be assured that your data is deleted. Without further ado, I hand over the floor to Amin.
Thank you, Vince, for this great introduction. So if you go to the next slide, before going through how we delete files in Hive, I would like to take a few minutes to give a quick overview of how hiveNet is built and how your data is stored on it. The hiveNet is made of thousands of Hivers computers located all around the world. A Hiver is a user who has installed the hiveDrive application on one of his devices and who is contributing at least 5 GB of storage space. These computers are interconnected to each other through a peer-to-peer network. This network is characterized by the dynamicity of its nodes. These nodes may join or leave the network freely. But don't worry, your data remains available and can be retrieved at any time and as soon as it is requested, like in any legacy centralized cloud storage solution. Now, let's see how your data is stored on our cloud. When you store a file on hiveNet, your file gets split into thousands of small pieces called shards. These shards are indexed inside hundreds of small structures organized on an hierarchical tree called Merkle Direct Acyclic Graph, or simply Merkle DAG. The DAGs and shards constituting your file are encrypted. Furthermore, each file or each object is encrypted by a unique key. Your objects are then replicated using erasure coding and disseminated across hiveNet. Thanks to erasure coding, the download of a file requires to retrieve only a subset of the disseminated objects, typically only 50%. As seen earlier, hiveNet is dynamic. The nodes leave and join the network at arbitrary times. To make your data available all the time, Hive's magic keeps monitoring the replication level of your objects. And if it goes under a certain safety threshold, new objects are regenerated using erasure coding and disseminated on new nodes. This process is called swarm healing. The swarm healing is a distributed process that runs across all the Hive nodes. In our next webinar, I will demonstrate how it works. Now, in the light of what we discussed earlier, let's explore together how challenging it is to delete content from such a distributed peer-to-peer storage system. The main difficulty lies in the mere fact that the storage system is designed to be survivable and to provide availability even when some nodes become unreachable. To enable complete deletion of an item, all its related shards and tags must be located and deleted. What is challenging is that the storage system, through its swarm healing process, will always maintain a number of copies available to guarantee availability and durability. This intrinsic behavior of hiveNet stands in contrast to what the deletion process tries to do. Additionally, as nodes may join or leave the system at arbitrary times, the objects that nodes hold may re-enter the system randomly in the future. By this occurs, the node at which the deletion request was initiated may be unavailable. The system should always know whether an object that has entered the system should in fact be deleted. And finally, secure deletion means that only authorized user should be allowed to delete a specific file. This is another challenging task, especially if we don't use centralized authority to manage access rights. So, this being said, I have good news for you. One, your stored files and folders on hiveDrive can be deleted in a safe and secure way, and I will explain later how this is done. And two, it is almost impossible for a hacker to destroy your data you store on hiveDrive. Now, let's see how we delete files on hiveDrive. First of all, each item in your hiveDrive is attached to a deletion key. This key is automatically generated the first time the item is uploaded to your drive. In order to be taken into account by hiveNet, a deletion request for any specific item must be signed with its corresponding deletion key. Once authenticated, a deletion request follows this step. First, we proceed with what we call an access-based deletion. This step consists in deleting all the references or links to your file from all the tags describing its parent folder. At this stage, you can undo the deletion and get your deleted file restored back. Then, a distributed garbage collection process that runs on all the active Hive nodes takes care of deleting all the orphan objects and keys from the local storages. We call this step data obliteration. As you have noticed here, Hive uses both encryption and signature to protect your data. The cryptographic algorithm used here are post-quantum resistant. For example, without the right encryption keys, the decryption of one piece of your data stored on Hive would take 2 times 10^32 years for a quantum computer, which is 10^20 times the age of the universe. Without these keys, a hacker need to break half of the Hive nodes simultaneously to get a chance to correct or delete your data, which is practically impossible. So thank you for your time and attention for reviewing together how the Hive distributed infrastructure, hiveNet, works, how your data stored in a reliable and secure way, and how the deletion process is implemented. To summarize, you can retrieve your files stored on hiveDrive even when some nodes that hold your data become unavailable. And thanks to swarm healing and strong encryption, it is nearly impossible for a hacker to read, corrupt, or delete your data. Now, I release the floor back to Vincent, who's gonna explain what are the benefits for the Hive users.
Wonderful. Thank you so much, Amin. It's honestly super exciting to see just how much work goes into a feature that, from a user like me, it feels so simple to right-click and delete. And yet it's really cool to know that behind that, there's a lot of what I consider to be magical to make it possible to delete these files and folders in a secure way in a distributed network. And now all that is really fun, but we can talk about what it does that brings you a benefit as a user of hiveDrive. And I think it's really interesting to look at these three things that Amin has talked about a little bit in more detail. First off, you can have a lot of confidence based on how the system operates that actually it's really hard to lose your files because your files are chucked into thousands of little bits and spread across the network and constantly being swarm healed, as we say. It's really hard for those files to get lost because they're constantly being regenerated. So that gives you a lot of confidence in the durability of the system. Because of that, we can also build on top of these cool features to give you things like really long-term version history and file restore features if you ever were to accidentally delete a file or wanted to go back in time for a previous version of your file. And ultimately, like Amin said, because again, the benefit of having these little chunks of your files stored in all these different nodes around the world, it makes it very difficult for someone to hold your data for ransom, even if they were to control dozens or hundreds of computers, because they would actually need to control a huge percentage of the Hive network to be able to really hold it for hostage. And that means that even if you were to have your files held ransom somewhere, you can rest assured that you'd still be able to reconstruct it and recapture it, even with those compromised nodes. Those are some of the most exciting features that I think that Delete will let us be able to build on top of and offer. But if we go to the next slide, we can talk a little bit about what are things that are coming and have come already this year. In Q4 of our last two releases, we started really building the infrastructure. And that's the foundation for what we're going to do in Q1, where we really want to focus on the main use case of being able to make it possible for you to store and access your files securely. Outside of just some really fun and cool new UI elements that are coming out, we're also really pleased to share that we're working really hard on a Linux, iOS, and Android version. These are things that we hear all the time from our users who want to be able to participate in the network for more than just a Windows or macOS device, and also to be able to access their data on the go when they need it the most. On top of that, we have exciting things like being able to integrate natively into the Explorer and Finder of macOS and Windows. And there's even some more surprises along the way that we'll announce closer to the release date in Q1 2023. But you don't have to wait for the end of Q1 to be able to start using Hive, because actually today it's already available, and you can go to hivenet.com, which you can see on the next slide, where you can download hiveDrive for free. And again, if you contribute 5 gigs or more, it's free to access with no upper limit. If you want to contribute 10 terabytes, you'll get 10 terabytes back for you to use. All in all, I really want to thank Amin again for giving us this really awesome explanation about how Delete works. And I'll hand the floor back over to David, who will wrap us through some final thoughts before we open the floor for questions.
Thank you very much, Vincent. Thank you very much, Amin. I'm really delighted how well you both have explained what is Hive, this hiveDrive, how everything works, and how delete feature is like a coin, has two sides. One is actually to obliterate data. The other one is actually to protect it. Who would have thought that peer-to-peer networks have such characteristics that really enable your data to be safe? So I just wanted to wrap up actually a little bit of 2022 for us. It's been an amazing 5 months over the last of the iteration of the existence of Hive, which was in June of this year. We started building a team, the team has come together and start doing monthly releases. And we really focused on the infrastructure with the goal of reliability and durability of your data as at the top of the priority. And we absolutely need to make sure that we also have a rhythm, a cadence, during which we improve Hive. And it was a lot of work, believe me, to put that cadence in place. And now it's working like a Swiss clock. This will enable us in Q1 to focus on new platforms and features and usability capabilities that Vincent mentioned a little bit. And we'll continue to keep you posted on so you can stay informed on hiveNet and your favorite social media. Please follow us if you're not already doing so, and tell us what you think. And without further ado, I'm also encouraging you to ask questions. So we have 4 questions that are here. I'm going to start with this question. What happens if a node never reconnects? Will they still have my data? Amin, would you like to take this one?
Yeah, sure. So basically, if a node does not reconnect, he will not be able to detect that some data is actually storing is orphan. So he will keep storing your data, but don't worry, he can't do anything with it. Basically, he's actually storing a very small piece of a file, or very small piece of a metadata in an encrypted format. And as I explained, it's gonna take 2 power 20 times the age of the universe to decrypt this single piece of data. So if it doesn't connect, it will keep storing your data, but can't do anything with it. But
Excellent.
maybe what I can add is, as soon as this node reconnects back to the network, he's gonna detect that some data are orphan and gonna destroy this data from its local storage.
Excellent. Thank you, Amin. Got lots of questions coming in. So another question is, does the hiveDrive dashboard show the locations where a user's data and DAGs are stored? I think, I mean, that could be you. I know that we don't show it, but maybe you have a better explanation than I do.
Yeah, okay, so basically today in the dashboard, we show the peers and the location of peers, nodes you are connected to at a given moment. Obviously, yes, we have the information, or we can retrieve the information where your data is located, but for the moment, we don't display it.
And I believe that there is a little bit of work that Vincent is considering as part of showing how your drive that you are sharing, the capacity you are sharing on hiveNet, is actually useful to all the other hivers, so that you can see how the community kind of works, together. Vincent, do you want to say a few words about that?
Yeah, you're quite right, David. That's one of the things we want to talk about, is indeed how we see 2 things. One is how my files and folders are being stored, because I think personally it's quite exciting to see how my files are distributed and split across and stored, even if it's an approximate area that we share. And on the flip side, it's also exciting, it's something we're working on, to be able to show you how many people you're helping store their files and folders, and how much you're contributing to the network to help provide this spare capacity to everybody. So those are 2 things that we're looking at doing for this coming year.
Very good, excellent. I have another very good question, actually. So the question is, does this mean that every giga of data that I upload, it has to be replicated several times on the Hive network? How do you make sure you don't run out of storage space? I mean, I think this one is also for you.
Yeah, so it's a very good question. So yes, each file you upload to Hive is replicated. And for replication, we use what we call erasure coding. So basically, we are generating parity data in a clever way, so that by retrieving only subsets of the disseminated data across the network, you can recover your original file. So how do you make sure you don't run out of storage space? So basically, we have some monitoring processes that monitor the available space on the Hive network. And if we detect that we are running out of storage space, we can automatically spawn some additional storage resources in some standard, let's say, data centers. And we're gonna power off this additional storage space as soon as new hivers join the network.
Thank you very much. I think I should add that we've also acquired a number of NAS devices that will be used once the bootstrapping is gone. And I will actually announce early next year a very special gift to the first few hundred of those NAS device owners that we will send these devices to create this overlay network that Amin has talked about. So stay tuned on this one. Another question is regarding the keys. So where are you storing the encryption keys and how are you securing them?
Indeed, very good question. So basically the keys are stored in the network like any other piece of information, DAGs, shards, and so on. And we follow what we call an hierarchical encryption to encrypt the keys, meaning that we have keys encrypting other keys. And the root secret for this encryption tree being your password, your master password you enter to unlock your workspace.
And how that password is stored on the machines? I mean, is this in a particular vault of the Windows and a Mac machine? And can you talk about that?
Yeah, so basically the keys encrypting your data are stored on Hive nodes, and these keys are encrypted in a hierarchical way. If we talk about the master key you should enter when you connect to the Hive network, the first time you enter this key is being stored on your local device, but we rely on the local vault of Windows or Mac to encrypt this key, so this master key. So this master key never leaves your local machine, and it is encrypted using the operating system features.
Exactly. Thank you. More questions are coming. There is one that I'm actually bringing up from a user who's referring to Hive as a cloud RAID in terms of the RAID system, the RAID storage system. And it seems to me that Hive could be called the cloud RAID. Is the sharding algorithm similar to RAID? I mean, I think that's one is also for you.
Yeah. Okay. So actually, we are using Reed Solomon as an ECC algorithm for generating shards. It's something used actually on RAID systems. But as you probably heard about it, we are collaborating with INRIA in wide projects. And one of the research axes we're gonna work on is to study and select new ECC algorithms adapted for such a storage system. But today it's same. Yeah, sorry.
Same algorithm. Yeah, exactly. Thank you for that. Let's continue. Another interesting question. What happens if a super large contributor like terabyte compared to the other contributors, gigabyte, does not reconnect? Could it endanger the availability of my files? Is there a tracking of the minimum connected nodes to hiveNet?
So I think this goes to me as well. So yeah,
technology.
So basically, we never store more than few shards related to the same file on the same server. Basically, and this way will limit the responsibility and we limit the risks on a single server. Basically, we for example, if we divide the file into thousands of shards, we're gonna store only one shard on each single server.
Excellent, got it. We are 1 minute away from the end of the allocated time for this webinar, which is coming much of questions. So I like this one. How long does it take to delete a file? Is it instantaneous? It depends.
It depends from which point of view. So basically, if you delete your file, from your point of view, from a functional point of view, your file is deleted immediately, and you recover the space consumed by this file immediately. But then we have, as I explained, we have this garbage collection process that runs in background that's gonna collect all the orphan objects and delete them from the local storages on the different nodes. But this is done behind the scene. You will not be affected by the duration of this garbage collection process.
Excellent. This will be our last question. Is it possible to select a subset of peers as a server to store data? So in other words, can I believe the question says, can I select subset of servers to store my data? And maybe you should talk about how do we, what's the algorithm to select those servers?
Yeah, so a very good question. So basically today we have this peer selection algorithm that works on different axes to select the best servers or the best node for storing your data. So we can consider diversity in terms of access providers, in terms of electricity provider or power provider, in terms of location of the nodes, so that if a disaster hits a specific geographical region, your data is not affected. But we have in our roadmap a feature called community-based node selection. Basically, you will be able in the future to select the nodes that will store your data. You can say, okay, I want my data to be stored only on the nodes managed by my company, or only on nodes belonging to my friends, or only nodes belonging to my family, or only nodes hosted on some specific area, for example, in France or in Europe. And this is the idea. But for the moment, this feature is not yet developed.
Thank you. We are a bit over the allocated time, so I appreciate obviously your answers, Amin and Vincent too, and all the participants who prepared this presentation, and obviously all the questions. There's one question I'll answer myself: how many nodes are contributing to Hive today? We have over 130 right now who are contributing, and we passed several terabytes of contributions. So we are growing. What I really like about the trajectory is it's so distributed, and the distribution actually creates a higher reliability than if everything was centralized, which is the essence, obviously, of Hive. In conclusion, thank you to everyone. As we go to the next slide, I would like to wish to you and your families a wonderful holiday season. We look forward to continuing to be connected with you and receiving your questions and feedback through a number of channels. You can also email me, which is david@hivenet.com. I'll be looking forward to answering your questions. If I fail to do so, during this webinar. Happy New Year and a wonderful holiday season.